All right. So in order for a voltaic cell to generate electricity, we have to generate the flow of electrons. So it has to be a spontaneous redox reaction that's going to take place. One of these two sides of the cell is going to act as an anode. One is going to act as a cathode. So what you would do is you would actually look, we've got silver on one side, we've got copper on the other. If you determine which of those two metals is the stronger reducing agent, the SRA, that's going to determine which is going to act as the SRA. And then you can also look at your ions, so Ag plus and copper 2 plus, which of those is a stronger oxidizing agent. So by doing that, we're going to see that the SOA, which is reduced, is the silver ion. Your SRA, which is oxidized, is the copper ion. In our reduction reaction, we have silver ions, so silver ions being converted to solid silver. So over time, we would expect this solid silver electrode to become larger in mass because we're creating solid silver. These electrons that are being supplied to the reduction reaction are coming from the oxidation reaction, and they're flowing, electrons flow in alphabetical order. They flow from the anode, the negative anode, to the positive cathode. So here we're providing the electrons for the reduction reaction. In order for this to be a complete circuit, so that these electrons will flow from anode to cathode, we have to have a complete circuit created here. So that's what this glass tube is for. It's called a U-tube because it's shaped like a U, and it's filled with a conducting electrolytic solution. So we've got this sodium ions, nitrate ions. Neither of them are taking place in the reaction, right? They're totally spectator ions, but they're providing that complete circuit that we need for electrons to flow. If we were to separate this wire here and attach something like a light bulb in the middle, we would see it glow because we've got a complete circuit that's been created. Probably put that in here. All right, so just to summarize, a way that you can remember this is your anode. What's taking place at the anode is an oxidation. This is your SRA. The anode is lose electrons oxidation happens at the anode. So you can think of it as LEOA. Gain electrons reduction happens at your cathode, so you can remember it as GER. So instead of LEO and GER, we're just going to add an A and a C to the end of those. So lose electron oxidation happens at the anode. This is your SRA. Gain electrons reduction happens at the cathode. This is your SOA. Guys, one more thing to note is that there are these spectator ions, these cations and anions, that are flowing throughout this circuit. It's to keep a balance of charge, to keep the voltage going. So we've got anions, which are these nitrate, and they're flowing towards the anode. So anions flow towards the anode. Cations, like your sodium ions, are flowing towards the cathode. So cations flow towards cathode. So that's easy to remember. Cat ions to cathode, anions to anode.